about chemical reactions. So a chemical reaction is when elements or compounds are going to interact, and through that interaction, they're actually going to be rearranged, right? So we separate these into two parts. We separate them into products and reactants. Products are the elements, the compounds, whatever I started with is a product. Reactants are what I end with. So we're going to start with products. We're going to rearrange those in order to get a reactant. So we're going to know that our products have become reactants, that a chemical reaction has occurred if we notice a change in temperature, a change in state of matter, or a visible change. So our changes in temperature. So reactions fall into two categories, exothermic and endothermic. Exothermic reactions give off heat. They're going to make their surroundings warmer. When you think of the big fiery explosions, those are definitely exothermic. And then endothermic, these are going to absorb heat. So these actually have the power to freeze their surroundings. If you've ever put salt on an ice cube, it gets really, really, really cold. That's because salt and ice have an endothermic reaction. So that's going to make it much, much colder in the surrounding area because it's absorbing all the heat. So changes in state of matter. So formations of a gas, so these can escape a container. So think vinegar and baking soda, it's going to produce that carbon dioxide gas. Now this is important, this can't escape a container part because it means you're not always going to see the gas that's produced. Sometimes it might escape the container and into the environment and you don't even notice it. And then the formation of a solid. So this is a big one. This is really cool. So this is when two or more liquids are going to react with a solid and they're going to actually create something called a precipitate. So these are going to create a precipitate. So two or more liquids are going to react. They're going to form a solid. We're going to call that solid a precipitate. All right, and then our last one is visible changes. So visible changes are going to be changes in color or the creation of light. So again, big fire explosions, we get that light or that bright flash of light you see with some reactions. So if it changes color or it produces light, it's a chemical reaction. Now, there are a few ways that we, as the scientists, can alter a chemical reaction. Typically, what we want to do here is we want to either speed it up or slow it down. So in order to speed it up, we're going to actually add energy into the system, right? So we're going to add energy, which is going to often result in the production of a gas or a liquid. So if it adds energy, it's going to speed up the reaction, or we're going to do everything in our power to keep that energy in that system low, right? So things that are going to add energy are going to be stirring the reactants, heating the reactants, or adding a catalyst. So a catalyst is a compound that its entire purpose is to speed up a chemical reaction. So a catalyst speeds up a chemical reaction. So if we're trying to slow it down, we might cool the reactants. We're definitely not going to stir it. We're going to try to minimize any kind of motion. We might even use a motion dampener, so that's going to keep it even from vibrating. And we're definitely not going to add a catalyst because catalysts are designed to speed it up. Now, the reason that adding energy is going to speed up the reaction, or why it's going to result in a gas or a liquid, is because the atoms in our three states of matter look very different. They all have a different level of energy. Solids have very low energy, and the atoms inside a solid don't move very much. Liquids move a moderate amount. They're mid-level, so the atoms are definitely going to move more. And our gases are going to have really rapid flowing movement from our atoms. So gases actually have the most energy naturally. Think about our atoms running all over the place, right? They're like a little kid on a sugar high. They've got so much energy. Our solids are going to have much, much, much less energy, so our atoms are going to move a lot less. And then our liquids are going to be right in that middle point. Now, by adding energy, our atoms are moving more often, and by moving more often, they're interacting more. They're interacting quicker, and they often have a more severe interaction. So by adding a catalyst, heating the reactants, or stirring, we're forcing that atomic movement, no matter the state of matter we begin with.